Hey guys, this is Michael from Calabasas Online Tutoring, and today is all about enzymes. Now, basically, enzymes are things that speed up a reaction, and they do this by making the reaction more likely to occur. So usually in a reaction, this would be the energy required, or the energy of activation needed, where this is the start and this is the end. So you see it has this big bump right here. Now, what an enzyme does is it has the same thing. It still has a bump, but it makes the bump less dramatic. So that means that it requires less energy to get over that energy of activation bump, which means the reaction will be more likely to occur. Now, this is important because enzymes can speed up the process by up to 10 million times faster. So if a scientist is collecting data and they have an experiment where it will take 2 years, then the process will be much faster and they won't have to wait all of that time. Now, let's go down to the microscopic level and see what's actually happening. So, with a reaction, when you're mixing an enzyme and a solution, let's say, you have the enzyme right here. So this bump is the enzyme. Now, this enzyme is right here, and this thin layer on top is called the active site. This is where the binding occurs. So your solution that you have, it's called a substrate. Now the substrate is the enzyme's active site and the substrate will bind together, but the active site is extremely selective on what type of substrate it wants. So let's say you have an active site that looks like this. Kind of looks like the energy thing from before, but don't associate with that. So let's say that's the active site right there. Now, if a substrate comes along and it's the exact fit for that, so let's say that's the substrate. Then it comes and it fits it and it binds to it. But if that substrate is off even by a little bit, so let's do like that. That's not a little bit, but you get the idea. Then it will not be able to bind to that active site. So the enzyme is very specific to the substrate that you're putting into it. Now, several things can affect this binding and whether or not it happens. There could be a dramatic change in temperature. There could be a change in pH, so it gets more acidic or more basic, which will affect the properties of both the enzyme and the substrate. Or an inhibitor could come along. Now basically, inhibitors, there's two types. There's competitive, and there's non-competitive. Now, let's start with competitive. So competitive inhibitors, they come up to the active site, which is specifically for a certain substrate, and they're a very similar shape, but not quite the exact shape. It still fits on, and it prevents the substrate from actually binding. So that's a competitive inhibitor. But let's zoom out of it because we need that for the non-competitive inhibitor. So let's say this is the entire enzyme right here, and that's the active, this part is the part we just saw. There is a section, probably, and it could be anywhere, called the allosteric site. Now, this could be an indent, could be another thing, and basically what it is if a non-competitive inhibitor comes along, so let's call that this curve the allosteric site. If a non-competitive inhibitor comes along and fits that allosteric site, then it changes the active site of the enzyme, which in turn prevents your certain substrate from binding to that enzyme and doing its reaction and speeding up the reaction. So basically, those are the two types of inhibitors, and that is basically what enzymes do and how they do it. So thank you guys for watching. I hope you enjoyed and I hope you learned something. Bye.